Hello, everyone. We are going to continue our work in Unit 3. We're going to look at Unit 3, lesson number 8, and we're still talking about the similarity of figures. So we've looked at this before, this graphic before, but what similar figures are figures that have the same shape, yet they do not need to have the same size. So we could create similar figures where we do either an enlargement or a reduction, right? We make a shape larger in size but the same shape, or we make it smaller in size. We can do that, but it has to maintain, again, all the angles must be equal in order for it to be similar. And we have to maintain a constant ratio of the sides, right? So that's what the scale factor does, right? So as long as we keep the same ratio between the side lengths and the shapes, right? So corresponding sides all linked together with the same ratio, and all the angles are the same, then we're gonna have similarity. If we're missing any one part, then we would say they aren't similar figures. Okay, so there's not that constant tie-in to each other. So let's look at the assignment kind of we have today and kind of walk through some problems and how we can kind of tell quickly if something is similar or not. So from the Kendall Hunt lesson, we start off with this assignment and we basically say, are these similar rectangles? Are they? So when we look here, right, rectangles have all of the same angles in them. If they're all 90-degree angles, I can agree that both of these are rectangles, but these are not similar, right? They're not. The reasoning behind this is that look at the original. The original has a dimension of 3 by 1, and the second has a dimension of 5 by 1, right? If one side gets bigger, the other one must also get larger. So you can't just stretch in one dimension. It has to do that in all sides, right? So even though these have all the same angles, the sides don't match, and so we can easily say this is not similar. All right, what if we're given some more information, right? We would have like two types of parallelograms here. Are these shapes similar? Well, so the first thing I look for is going to be the angles, right? If any one angle does not fit with the other, then it's automatically not similar. It's only after we look at the angles, then do we look at the side lengths, okay? So if we look at these angles, we've got two angles in each that have a single tick, two that have a double. So this is, at least the angles are matching up so far. Now, when we look here, look at the side lengths, there needs to be a constant ratio of the um, sides that work together. Now, you may remember that all triangles with their angles all equal to each other, they're all similar, but that's where it stops. Quadrilaterals don't have that property, only triangles. So if we look here, we've kind of got our short sides and long sides, right? So I would say that like the long side here is 42, the short side here is 30. If we look over on the other side, we have a long side of 42 and sort of a short side of 25, right? So this is not working, right? So this is a no, right? In order for this to have made sense, right, the other side, right, the triangle on the right would have to have the bottom and top be 30 kilometers, since the left and right sides would be 42. This is a big no. Again, there's other ways this could have been similar, maybe if the numbers were different. But again, I can see really quickly there that we don't have to worry about that. Okay, so what about these shapes, right? So when I look here at these shapes, I see everything has we have all right angles in both shapes. That's great, right? So then we move along to the side lengths. I see this is a square, right? So we see 20, 20, 20, and 20. On the other side, I see 22, 22, 22, and 22, right? These are both squares. All squares are going to be similar to each other. This is a yes, right? So we see a ratio between the two of them. So if we were to go from one to the other, we would be multiplying by the end over the start, which is 20 over 22, which again, this could also be 11 tenths, right? So it's just a little bit bigger, just a little bit bigger, but that is fine, right? As long as the angles are the same and there's a constant ratio between the two of them, because all the side lengths are equal in each figure, they're squares, and so we know that that's going to hold. Not all questions are always that simple, right? We may have a triangle where all the side lengths are different. So then we're going to have to check and see what those ratios come out to be individually, right? So remember, the key here is that all of the corresponding pieces have to have that same ratio. Okay, so when we look at these two shapes, are they similar, right? I see they each have a right angle, a single arc, and a double, right? So that matches, right? So this means that these should be similar triangles, right? Because triangles with all the same angles have to be. But let's just check to make sure, and you can see how the side lengths work, just in case they're playing some sort of evil trick on us here. So first, we're going to look at the smallest sides. This would be my suggestion. Would be look at the smallest ones. So the small sides here. We're going to do 675 divided by 450. So let's see what that is. You could divide this on your calculator on your phone. It'll probably give you a decimal point. This gives me 1.5, right? So 1.5 times larger. I'm going to see my medium side. My medium side here is going to be 750 and 90. Oh, sorry, that's the wrong one. Sorry. Should have proved that. 600 and 900, right? So again, just make sure that you're checking that also. You can see I almost made a quick mistake and kind of figured it out. But again, the medium side, the side in the middle of length is going to be 900 on the right, or the end, 600 here. This does have this will divide as 1.5. And then we'll finally close off with 750 and 1125. So our large side will be 1125. We divide that by 750. Again, this is also, if we use a calculator, gives us 1.5. So the fact that all three of these sides, all three of these ratios are the same and all the angles are the same, that's a yes. Now, we should know automatically with triangles that this is the case, right? Triangles with all the same angles should be similar automatically. We just wanted to check to make sure there wasn't some silly shenanigans happening with this one. Now, with quadrilaterals and more many-sided shapes, that's not true, right? So we always want to make sure we check. But I recommend checking, based off of kind of the relationship of the sides. So like small, medium, large kind of works pretty well.